All right, today we're going to start Unit 7. We're going to be looking at properties of exponents and also reviewing some scientific notation because scientific notation also uses exponents. So we want you to be able to use some properties of exponents to multiply and divide monomials and also be able to use expressions that are in scientific notation. Now, when we talk about simplifying an expression that contains exponent or powers, that means to rewrite the expression without any uh, parentheses. Also, we want to rewrite it without any negative exponents. So you should only see variables written one at a time with their powers. So to simplify an expression without any parentheses or negative exponents. All right, so some terms that are some different things that you should be able to do here is anytime you are doing a product of powers, that means you are multiplying monomials. You want to add together their exponents. Okay, and the reason that is if we're multiplying x squared times x to the third times x to the fourth, x squared means you're multiplying two x's. X to the third means you're multiplying three x's. X to the fourth means you're doing repeated multiplication. You got four x's. Total here, that means we got 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So this is equal to x to the ninth power. And that's because we add all these up. 2 plus 3 plus 4. If we add all those exponents, that's 9. So the answer would be x to the ninth. All right, here's another example. M times m squared. Now, you got to know anytime they don't show an exponent that the exponent here is 1. So this would be equal to, if we add the exponents here, 1 plus 2 is m to the third power. Also referred to as m cubed when it's to the third power. All right. Another property of exponents is when you have a power to another power. So in this example, we got y squared being taken to the fourth power. Now remember, what does it mean when something's being taken to the fourth power? That means there's 4 of them. So that means we got y squared times y squared times y squared 4 times. So if we just use that property we just had, 2 plus 2 plus 2 plus 2, that should be y to the 8th power is what this should equal. Well, the quicker way of doing that, rather than having to write that out, would be to multiply. If you take 2 times 4, you get 8. So when you're taking a power to another power, multiply the exponents. Let's look at another example down here. So the second one, okay, we got it to the third power. That means all this stuff in here, if it's being multiplied, if it's a single term, everything should get taken to the third power. So this is going to be 4 to the third power. Now we got power to another power here, x squared to the third power. 2 times 3 is going to be x to the 6th power. And y, this is like a 1 here. 1 times 3 is going to be 3. Now, the variable ones we can't really do anything with. This number one, though, we can see what that equals. So if you go on your calculator, you should be able to do 4 to the third power. So hit 4. Your exponent button is this caret one that kind of looks like a triangle. And then type in your exponent. It's 64. 4 times 4 times 4 is 64. So then we can write this as 64 x to the 6 y cubed. That's simplified. Okay, another one is quotient of powers. Quotient means that you are dividing. So if we think back to what we just did a couple times ago when we did product of powers, if you multiply, you add. So it would make sense then that if we are dividing, that means we need to subtract the exponents. So on this first example here, we got 11 and 5. If we subtract those, we're going to get m to the 6th power. Now, m to the 6th power is not our answer, though, because if we look, 11 is on the bottom. The bigger one's on the bottom. That means once we're done simplifying, these 6 m's that are left over are going to be on the bottom of our fraction. None of the m's on top are going to be left. which means we got to fill something in on top. So if you need to, anytime you need to fill something in on top where there's nothing left, you fill in a 1. Because really what we have here is there's 5 m's on top. There's 11 of these on bottom. Okay, and so what we can do is basically you're just kind of canceling them out here. And what you're left with is 6 of these m's left on bottom. Okay, there's nothing left on top, so we fill it in with a 1. All right, the second one, same thing, subtract them. Here the bigger ones on top, 7 minus 3 is going to be a to the 4th power. Again, you could put a 1 and fill in the bottom, but if something's over 1, you don't need to write that, so we could just leave it as a to the 4th power. If it's on the denominator, though, you have to put a 1 on top. You got to fill something in the numerator. You can't leave the numerator blank. All right, the next one, negative exponents. When we are doing anything with negative exponents, we try not to leave negative exponents in our final answer. So to fix a negative exponent, move it to the inverse side of the fraction, or the other side of the fraction, and that makes it a positive exponent. So let's look at some examples here. 3a to the negative 5th power. The negative 5 goes with the a. Okay, so we want to move that to the other side of the fraction. Right now, this is not a fraction. So what we're going to do is make it into one. Okay, the 3 doesn't have a negative exponent. So we're going to leave the 3 on the top. What we're going to do, though, is move this a to the 5th, a to the negative 5 to the bottom. And when we do that, instead of a negative 5, it's going to become a positive 5. And now we have an answer that doesn't have any negative exponents. It's the equivalent of what we started with, just written without any negative exponents. Okay, same thing on B, or on the next one here. Negative 3, we don't want to leave a negative 1. We're going to move it to the other side of the fraction. So we're going to move it up to the numerator. 2's already there, so we're going to leave the 2 there. This would now be x to the positive 3rd power instead of negative 3rd power. Nothing's left on bottom, so you could put it over 1 again if you want. You don't have to when it's on the bottom. We could just say the answer is 2x cubed. So negative ones, you want to move to the other side of the fraction. Last one, anything to the 0 power. You can try this on your calculator. If you take anything to the power of 0, it's always 1. So this first one, you can see it's power of 0 out here. It doesn't matter what's in here. Answer's 1. Okay. On the second one, notice the 0 here only goes with this. So x to the 0 power, that equals 1. But here there's a 5 that doesn't have a power of 0. So that's 5 times 1. So here the answer would be 5. So whatever's taken to the 0 power equals 1. If there's other stuff, then you multiply it to that. All right, now we're going to try some problems where you might have to combine some of these types of properties into a single problem. So on number 1 here, we want to try to simplify this. So when you go through, multiply together like things here. So let's start with the numbers. 3 times negative 4, that's going to be negative 12. Now let's look at our x's. We got x squared, and there's another x squared here. It's not power to a power, so what we want to do then is add the exponents like we talked about before. 2 plus 2, that's going to be x to the 4th. And then finally we got y squared and y to the 4th. Again, we want to add when we're multiplying. That's going to be y to the 6th power. And there's our answer. So that would be the simplified solution to that one. All right, let's try out number 2. This one, we got 3 things being multiplied. That's fine. We just want to go through and do the same thing. So look for any of them that are the same. It looks like the only 2 the same are right here. There's 2 of these a's. So if we combine those together, we're going to get, we got to add them. Negative 3 plus 2 is negative 1. And we still have a b to the 4th and a c to the negative 1. Now remember, we don't want to leave negative exponents in our final answer. So now we need to write this without negative exponents. So we want to move both the negative ones to the other side of the fraction. In this case, it means moving it down to the denominator. So the final answer on this one, B already has a positive one. We're going to leave that one where it's at. If A goes to the bottom, it's going to be to the positive first power now. And same with C, to the positive first power. If something's to the first power, you don't need to write the exponent. So you could also write this answer as B to the fourth over AC. And that would be the simplified answer. All right, number 3. We want to simplify here. We're dividing, which means we should subtract. We're going to subtract these. 8 minus 3 is going to be p to the 5th power. Now we got to figure out, should it go on top or bottom? Well, the more of the p's are on bottom, so it looks like the p to the 5th here is going to end up on the bottom, which means the top we need to fill in with a 1. So 1 over p to the 5th would be the answer. All right, let's try number 4. Again, we're dividing here, so let's divide our numbers first. If we take 15 divided by negative 3, we're going to get negative 5. Okay, now we got c to the 5th divided by c squared. If we subtract the exponents, we're going to get c to the 3rd power. But looks like I missed one here. We still have some c's. Let's combine those c's first. Okay, if there's multiple things on one side of the fraction, that's probably the best thing to do first. So I'm going to go back here. Let's do that. I missed that. So if we're multiplying, we know we should add the exponents here. That's going to be c to the 9th power. Now let's do our division. So like we said before, we're going to get negative 5. Now if we minus here, it looks like there's actually more c's on the bottom. 9 minus 5 is going to be 4. So we're going to have c to the positive 4th in the denominator. This is the only d, so we'll just leave the d to the 3rd power on top. There's the simplified answer. All right, flip to the back of your note sheet here. Let's look at 2 more, and then we'll talk about some scientific notation. Number 5, we got something to the 5th power here. Now, we want to check to make sure, is it just one term here? And it looks like, yes, it is. There's no pluses or minuses in here. It's just a single thing. So that means we can go through, and we need to take everything to the 5th power on here. So we're going to end up with negative 2 to the 5th power. We're going to have to take p cubed to the 5th power. Now remember, sums to the 5th power again, that means you're multiplying 5 of those things together. If we multiply 5p to the 3rd power is 3, 6, 9, 12, 15 of them, we should end up with 15 p's. The quicker way of doing that is just to multiply. If you multiply 3 and 5, you get p to the 15th power. Same thing here, r squared to the 5th power, power to a power, multiply. It's going to be r to the 10th power. All right, the last thing we got to do, though, is simplify. What's this? What's negative 2 to the 5th power? So go on your calculator, type that in, or you could just multiply negative 2 to itself 5 times. Calculator's probably a little faster here. Negative 2 to the 5th power is negative 32. Always make sure if you're taking a negative number to a power that you put it in parentheses on your calculator. So the final answer here is negative 32, p to the 15th, r to the 10th. All right, last one. It's a fraction being taken to power. Even if it's a fraction, you still take everything to that power as long as it's a monomial. So on this one, we're going to end up with a to the negative 3rd power. That needs that power. And then on the bottom, 4 is going to be taken to the negative 3rd power. Well, both of these are negative. We don't want to leave an answer with a negative. So for this one to become positive, we want to move it up to the numerator. For this a term to become positive, we want to move it down to the denominator. So then it'd be 4 to the positive 3rd power over a to the positive 3rd power. Last thing we want to do now is see what is 4 to the 3rd power. So that's where you'd use your calculator, do 4 times 4 times 4. I think we did that one before. It looks like 4 to the 3rd power is 64. So our final answer on this one would be 64 over a to the 3rd power. That's a simplified way to write it. All right, so that's properties of exponents. You're going to be practicing some of that later here. The other thing we're going to be looking at is scientific notation. Okay, scientific notation is a way to write really big numbers or really small numbers. When you have something in scientific notation, it's always written in this form, where you're going to have some number A that's between 1 and 10 times 10 to some power, where n is going to be a whole number or an integer. So some kind of um, number that's not a decimal or fraction. All right. So scientific notation, you've learned about that a little bit in science class. You should have talked about it when you're in algebra 2, but just kind of review. If you have a number like 88,900 here and you want to write it in scientific notation, you want the decimal point to end up after the first non-zero number. So right now, decimal points here, we want it to end up right there after the 8, because that's the first non-zero number. So then you want to figure out, well, how many place values do you need to move it? 1, 2, 3 times. So we would write this as 8.9 times 10, and then since we moved it 1, 2, 3 times here to the power of 3. So that's how you write it in scientific notation. All right. So oftentimes you use scientific notation when you're dealing with large or small numbers here. This problem uses it. So if we read through number 7, it says the density of an object in grams per milliliter is found by dividing the mass of a substance by the volume of the object. A sample of platinum has a mass of 8.4 times 10 to the negative 2 kilogram and a volume of 4 times 10 to the negative 6 cubic meter. Use this information to calculate the density. So they just said density is mass over volume. If we want to calculate this out, then we need to divide the mass, which is 8.4 times 10 to the negative 2, and divide that by the volume, which is 4 times 10 to the negative 6. Okay, if we're dividing this now, what we can do is use some of our stuff we've done before. Let's divide the numbers first. If we divide 8.4 by 4 on our calculator, let's see what we get. 8.4 divided by 4 is 2.1. So that's going to be 2.1. Now we want to divide the powers of 10. Now here's where you got to go back to what we just learned. What do you do when you're dividing out powers? You need to subtract. Now both of these are negative right now. It might be easier to divide them if we were to make them positive. So what would this look like if we made it positive? Let's do that here. Let's change these to positive ones. So if we switch them around, if we move this one up and this one down, this would be 10 to the positive 6. And this one would become 10 to the positive 2. Now it's a little bit easier to subtract these. If we take 6 and subtract 2, this is going to end up being 10 to the 4th power. So that would be our density of this object. And it would be in, looks like kilograms per cubic meters. That's how you would write the density. All right, let's try some other problems that would use scientific notation. This one says, after the sun, the next closest star to Earth is Alpha Centauri C, which is about 4 times 10 to the 16th meters away. How long does it take light from Alpha Centauri C to reach Earth? Okay, well, to do this, we need to know how to relate distance, which we have a distance here of this, a rate, which is like speed, and we have that. We know that light travels at a speed of approximately 3 times 10 to the 8th meters per second. And then what we're trying to figure out is how much time, how long. So we're trying to figure out time. All right, well, let's plug in what we know then. We have a distance. We use our little distance equals rate times time here. Our distance is 4 times 10 to the 16th. Our rate is 3 times 10 to the 8th multiplied to our time. Well, if we're going to solve this and we want to get t by itself, it looks like we're going to have to divide both sides here by 3 times 10 to the 8th. So that cancels out. So our answer here for time should be whatever we get when we make this division. Well, let's do the same thing we just did on the last problem. Let's divide our numbers. So let's divide 4 and 3. So if we take 4 divided by 3, it's about 1.33333. And we can round because we're doing scientific notation. It's not exact here. Times 10. Now we got to figure out what's the power exponent of 10 going to be. Well, powers, when you're dividing, you want to subtract. We got 16 and 8. So if we take 16 minus 8, we end up with 1.3 times 10 to the 8th. And we were dealing in meters here and seconds. So the meters cancel out. Looks like our time is going to be in seconds. So it's going to take 1.3 times 10 to the 8th seconds to reach Earth. How long is that? Because in seconds, that doesn't really make much sense. It's hard to picture what that is. Let's change that into something we're more comfortable with. We did this kind of thing before, if you recall. If this is in seconds, and let's try to change it into something we're more comfortable with. So let's start to maybe change it to minutes first. What would this be in minutes? Well, if we're going to change to minutes, we need something that's equivalent. And we know 60 seconds in 1 minute. Should we put 60 seconds up here? No, because then seconds can't cancel out. We want seconds to cancel out. So we want to put seconds on bottom and 1 minute on top, because now we got seconds on top, seconds on bottom. Those cancel out. We'd be in minutes. So if we divide, it looks like by 60, that would change it to minutes. I think we're going to need to do a little bit more than that, though. I forgot our 10 to the 8th here. Let's keep going. If we go to hours, we know that there's 60 minutes in 1 hour, and let's keep going here. And we know there's 24 hours in 1 day. And let's even go to years. Let's see what this is in years. We know there's about 365 days in 1 year. So a lot of our units are going to cancel here. And if we divide by all these numbers, we should get this into years. So let's keep dividing this number and see what we get. So if we got this number times 10 to the 8th power, that's this. Let's divide that by 60. So that's what it would be in minutes. Let's divide it again by 60. That's in hours. Let's divide it by 24. That's how many days. Let's divide it by 365. So it's about, this is the same as about 4.2 years. So it takes light, even moving at this astronomically fast speed, 3 times 10 to the 8th meters per second. That means it's moving that many meters in 1 second. That's very fast. Even traveling that fast, light takes over 4 years to go from that star to Earth. So if that star were to, say, blow up today, we would still see the light from it for 4 years. We wouldn't even know it blew up till 4 years later. That's how long it takes that light to come here. So that's quite a distance. All right, one last one, very similar. Why don't you pause the video, try this one out on your own first, and then we'll see what you get. All right, let's see what you got. You got another distance here, and we're still dealing with the speed here. So if you have your distance of 3.84 times 10 to the 8th, we have a rate of 3 times 10 to the 8th times our time. Looks like, again, you got to divide on this one. This cancels out, so our time here would be whatever we get when we get this. If we do 3.84 divided by 3, that's 1.28. And then we got to subtract our exponents here. They're both 8, so if you do 8 minus 8, that's going to be 10 to the 0 power. Well, we already know anything to the 0 power, that's the same as 1. So we got 1.28 times 1. Well, anything times 1 is just itself. So it looks like on this one it takes 1.28 seconds. So if you make a communication to the moon, that's what this one was talking about, to the moon, it's going to take that radio signal to travel. It takes a little over a second for it to travel to Earth. That's why if you've ever seen on like TV where they're talking to the astronauts up in space, and they talk to them, the astronauts usually sit there for like a second or two before they respond. That's the time it takes that signal to go all the way up to where they are in space. There's a little time lapse there. All right, you guys try some of the practice problems out on your